this is my CNC machine. So it's been finished sort of and working for about a month now, so I figured I should finally do a video on it. And yeah, here it is as you see it now. It's cutting parts, as you can see. It's quite messy. So I'll just give you a rundown of all the parts and how it works and why I did what I did. So a bit of background. Last year I went to a robot competition in the UK, and a lot of the guys there build CNC produced robots out of aluminium, and I really liked what I saw over there. And I already had the milling machine, so I figured I might as well CNC this. I've already CNC'd a laser cutter of mine in a very similar way. It uses Linux CNC and steppers and standard stepper drivers and whatnot, so I already had a bit of experience with it. But geez, what a journey and adventure this has been. It's just been a huge task, way bigger than I initially thought. The building of it wasn't too bad, but geez, just all the programming and learning the cam and the speeds and feeds and everything. Even now I only feel like a beginner, so you know, I am. But yeah, it's a pretty tall task to get one of these things together and working very well. So yeah. And the other reason I built it is I work pretty long hours, so I just don't have the time anymore to come outside after I get home from work and start throwing an angle grinder around, making a lot of noise and things. So I built a plasma cutter at work as well to complement this. So it's much better for me to just, you know, spend the time after work planning and CADing and camming and whatnot. Then I'll just come out here on the weekends or in the morning and just run the parts and whatever. So it's working pretty well at the moment. Hopefully ready to start making a new robot for next year's competition in the UK. And yeah, so let's run through some of the parts. Right, so the first thing is my custom built stand. It's all made of 50 by 50 by 2 SHS. It's fairly rigid. It does still vibrate a little bit, but I don't think I can really make it any better. So whatever. So I did see, I can't remember the website, but I saw another person with a RF45 mill. It's the next size up from this one, basically. And they built their tool cabinet inside of the stand. And I don't have a lot of room here, so I thought that was an absolutely awesome idea, so I copied it pretty much in its entirety. So at the moment it's still got all my sockets and other tools, but slowly converting into the CNC drawer. Whoop, that's not it. There we go. So this is my Tormark TTS drawer, still populating it. I think I've got 52 tool spaces, which I believe is about what it works out to in Linux CNC. You can only have 52 in the tool table, but I've got most of the basics now. I'm pretty happy with it. So I still got to wait for my 3/4 inch drill bits so I can finish those off, because that stupid Glenn bought the wrong one. Righto. Next things next. So it's an open workshop. It's not enclosed, it's just an old carport, so I don't really, as I said, I don't have a lot of room, but it's also very dusty, and there's also a lot of welding and grinding going on, so I didn't really want to have an external computer or electronics box. So to keep space, you know, efficient, make an efficient use of the space, I built all the electronics into the bottom drawer, so let's have a quick look at that. So starting off, I've just got an Angel Eye push button light that wires into the computer for the on and off. I'll come back to it, but geez, that was a huge pain for some reason. So, lo and behold, there's the electronics. It's all tucked into the drawer. Geez, it's tight in there. I thought there might just be enough space by measuring it up, and it was all millimeter perfect. If I did, would I do it again? Yeah, probably. Like, it's pretty slick when it's all together, but just running all the cables and stuff was a bit of a pain, so I don't know, maybe next time I would have just put it in a separate sort of IP66 sealed enclosure, whatever. But hey, that's the way we did it. Alright, let's go left to right. So the power supply, that's a Meanwell 48 volts, what do we got? 12.5 amp, which is perfectly sort of matched to the setup I've got. I'm really happy with it. I got that one from Home and Designs. He was a lot of help personally as well, getting the spindle working. We'll come back to that. So originally I had a TDK Lambda, I think it was 50 volts at either 15 or 20 amps. It was a monster power supply. It was even bigger than that one. And I got it for a steal from eBay off an Israeli seller. Unfortunately, it was DOA, so that was a bit annoying, but that's what happens sometimes. Nonetheless, Meanwell's been fantastic, if a little bit noisy, but whatever. So next up we've got the Leadshine MX3660. I took a bit of a gamble on that one. There's not a lot of information going around. A lot of the American guys are still huge on the Gecko G540, which I have in my laser cutter, and it is really good, but it just doesn't have the power to drive these steppers at the sort of voltage and current that I wanted to run them at. So I believe it's Chinese made, but really it's been, so far it's just been perfect really. Steppers are quiet, there's no resonance to it. The current limiting works really well. The steppers barely get hot when they're sitting at idle. I've left this thing on literally all day with no problems. It's got all 3 stepper drivers built into it, breakout board, everything on there really. You can drive I think it's got a built-in ADC or DAC, can't remember, for driving a VFD or the spindle, which does work pretty well, but it's got a little bit of an annoying flaw. Mainly it's opto isolated, so it does knock a bit of the peak voltage off, which means you can't drive the spindle at 100%, which is kind of annoying without an extra add-on, which I haven't got, but whatever, does the job for now. The other thing with it is the documentation. It's okay, but the wiring diagrams are just completely wrong, especially for the inductive limit switches. And I think the VFD side of it was not really documented well either. But with a bit of trial and error we got there in the end. Nonetheless, really good product, happy with it. It was cheap considering, so love it. Just behind there are the speak-on connectors for all the steppers. There's 4 of it in there in case I wanted to add a 4th axis later, but for now just 3 of them. Bolts to an aluminium subplate. All the electronics go on a subplate, so you can undo the speak-on connectors and just pull it out if you need to do any maintenance or anything like that. So that box on top there, the little Jiffy box with the relay next to it, that's the spindle control and the coolant control. So the relay is just for the coolant. That drives straight off the Leadshine. I believe there's a transistor switch in there as well. Can't quite recall. Pretty sure there's a transistor switch. And there's also an Arduino in there that actually interfaces to the spindle. We'll come back to that later, which was a huge task though, but the spindle does work in the end off the Leadshine VFD driver, so I'm quite happy with that. And last but not least, the PC was a Dell Optiplex from a M-Wave that was on sale. I think it was only $70, pretty cheap. Surprisingly powerful. It's got a parallel port built into it. I've also got a Mesa, I think it's a 5i25 card, but it's not running it at the moment. I didn't know what performance I'd get off the Dell computer, so I just bought one as a matter of course. I'm sure I'll need to use it eventually, but you know, it's there if the option is required. And lastly, because it's all in there quite damn tight, especially when it's shut, there's no airspace whatsoever. So the first time I ran it, it almost immediately overheated. So now it's got a grill just in front of the motor. You can't see that at the moment, but the airflow basically goes in the computer, out the back, in through the back of the power supply, in the front, and then there's a PC fan, just a normal 12 volt, 24 volt, sorry, no 12 volt fan, and it just blows out front, and it works perfect. Super happy with it. So that's the electronics.